Welcome to Crashcast Java, where we dive deep into Java concepts to help you become a better developer. I'm Victor, and today we're joined by Sheila to discuss a powerful data structure in Java, the concurrent hash map.
Thanks, Victor. I'm excited to explore this topic with our listeners. Concurrent HashMap is a thread-safe version of HashMap that was introduced in Java 5. It's still very relevant today, especially in multi-threaded applications.
Absolutely, Sheila. Let's start with the basics. Can you give us a quick overview of what a concurrent hash map is?
Sure thing, Victor. A concurrent HashMap is essentially a thread-safe version of the traditional HashMap. It allows multiple threads to read and write to the map simultaneously without causing data corruption or inconsistencies. Think of it as a bank with multiple counters, where each counter can handle transactions independently.
That's a great analogy, Sheila. So how does it differ from a regular hash map in terms of thread safety?
Well, Victor, unlike a regular HashMap, which can cause issues if multiple threads access it simultaneously, concurrent HashMap is designed to handle concurrent access. It achieves this by dividing the map into segments, each of which can be locked independently. This means that multiple threads can work on different segments at the same time, improving overall performance.
Interesting. Can you elaborate on how this segmentation works?
Certainly. Internally, concurrent HashMap is divided into multiple segments, also known as buckets. Each segment is essentially a small HashMap that can be locked independently. When a thread needs to modify the map, it only locks the relevant segment, allowing other threads to work on different segments concurrently. This approach significantly reduces contention between threads.
That sounds really efficient. Can you give us an example of where concurrent HashMap might be particularly useful in a real-world scenario?
Absolutely, Victor. Imagine a high-traffic e-commerce website that needs to keep track of product inventory in real time. Multiple users might be viewing products, adding items to their carts, and completing purchases simultaneously. Using a concurrent HashMap to store product information and inventory counts would allow the system to handle these concurrent operations efficiently without risking data inconsistencies or the need for excessive locking.
That's a great example, Sheila. Now let's talk about performance. How does concurrent HashMap compare to synchronized versions of HashMap?
Good question, Victor. Concurrent HashMap generally offers better performance than using a synchronized HashMap, especially in scenarios with high concurrency. The fine-grained locking mechanism allows for better scalability as the number of threads increases. However, it's worth noting that for very small maps or low concurrency situations, a synchronized HashMap might perform slightly better due to less overhead.
Interesting point about the trade-offs. Are there any common pitfalls or misunderstandings about concurrent HashMap that developers should be aware of?
Yes, there are a few things to keep in mind. First, while concurrent HashMap is thread-safe for individual operations, it doesn't provide atomic operations for compound actions. For example, check-then-act or read-then-write operations aren't atomic by default. Developers need to use methods like put-if-absent or compute for these scenarios.
That's an important distinction. Any other best practices you'd recommend?
Absolutely. It's crucial to choose the right initial capacity and load factor when creating a concurrent HashMap, as resizing can be expensive. Also, avoid using null keys or values, as concurrent HashMap doesn't allow them. Lastly, remember that iterators from concurrent HashMap are weakly consistent, meaning they may not reflect the latest state of the map if modifications occur during iteration.
Great advice, Sheila. As we wrap up, could you mention a few advanced topics related to concurrent HashMap that our more experienced listeners might want to explore further?
Certainly, Victor. For those looking to dive deeper, I'd recommend exploring these 3 areas. First, custom concurrency levels and how they affect performance. Second, using weak keys and values in concurrent HashMap for specific use cases. And third, understanding the implications of concurrent HashMap in the context of the Java memory model.
Excellent suggestions, Sheila. Thank you for sharing your expertise on concurrent HashMap. To our listeners, we hope you found this episode informative and engaging. Remember, concurrent HashMap is a powerful tool in Java's concurrent collections, but like any tool, it's important to understand when and how to use it effectively. Thanks for tuning into Crashcast Java, and we encourage you to subscribe for more deep dives into Java concepts. Until next time.